Here we go, 227 and 228, let's do it. This question is asking you to compute a 95% confidence interval for the slope. So when we do a 95% confidence interval, based on our formula, it is whatever our point estimate is, plus or minus the margin of error. And the margin of error, in our formula sheet, the margin of error is the critical value times the standard deviation of the statistic. And this is, or the standard deviation of the point estimate, right? This is whatever the statistic we are collecting. Well, they've asked us to do the slope. So this is the slope plus or minus whatever critical value. Now they've told us we want to do a 95% confidence interval. So the critical value from the table, 95, we would maybe accidentally put 1.96. But notice the critical value here is not there at all. 1.96 is only for proportion questions, not quantitative questions. And this is definitely a we have quantities. In fact, we have two quantitative variables. So this is a least squared regression line, and they've asked us to calculate the slope of that least squared regression line. So this is technically a chapter 12 question. But anyway, let's continue. So I need a critical value here, and the standard deviation of the statistic we get right out of the graph. So I'm going to use this as a perfect example. They could give you this as a free response question, and I'm going to show you how you would break this down. So anytime you get a formula like this, a readout, you do the following. You write y hat, the predicted y value, plus equals a plus bx. So my predicted y value, we read, what am I trying to predict? It says we're trying to use this to predict my final exam score. So this is my final exam score. And A is my constant. A is my constant, so they give that value right there, 62.328. B is my slope, that's the number right underneath my constant, 2.2697, and X is this right here, study hours. So the more I study, the higher my score will be, right? And that makes sense. There is we want to LSD. We want to say there's a positive linear, we want to give the direction. There's a positive linear, maybe strong, we don't know, but there's a relationship between these two. And they could ask you to define the slope. So as for every hour of studying I do, my final exam score goes up by almost 3 points. So, what else could they ask? They could tell you they could say, okay, somebody studied 9 hours, calculate their final exam, right? But in this question, they merely ask us to do a confidence interval about the slope. So, you need to know that the standard deviation of the statistic is right next door to the slope. This is the slope. And this is the standard deviation of the statistic, and that's my statistic. So that's the number that goes right here, 0.745. And so when I look at that here, it's only A that is the number 0.745. That's it. That's the only other number. But I also want to talk about where this number came from, because that's important too. I'm going to go back to my table and look for that number, 2.228. There it is, and interesting, it is on the line of 95%, 2.228, and it's on the degree of freedom of 10. So the degree of freedom of 10, table B gives us a critical value of 2.228, and that's definitely my answer. And I'm saying to myself, what? Where'd that come from? So looking up in my problem, it says that there were 12 students. And so normally the degree of freedom formula is n minus 1, but notice we have 2 quantitative variables. So let's think about a slightly different formula. The degree of freedom for a question like this, when I have 2 quantitative variables, would be n minus 2. Therefore, it should make sense. I got 10 when I subtracted 12 from 2. Now let's take a look at the next question, and oh, it's a tricky one. 228. I remember a few years ago, this question really frustrated me a little bit because I wish they would add one more word to this. So let's read the question. The question states, a mathematics competition uses the following score procedure to discourage people from guessing. So for each correct response, the score is 7. So I'm just going to make a table here. This is my points. If I get it correct, I get 7. It says for each incorrect, you get nothing. And if you leave it blank, you end up actually getting 2 points. So let's keep reading. It says for each, I read that. For each incorrect, I get 0. There's 5 choices. So kind of like here, there's 5 choices. And so you're looking on a multiple choice test. If you have 5 choices, if you're purely guessing, the probability of getting it right, if you're purely guessing, is 1 in 5. You could also think of that as 20%, 1 divided by 5, if there's 5 choices and you're totally guessing. Now, they said if there are 5 choices, what's the minimum number of choices a student must eliminate before it's advantageous? Now, here's what I wish they would add to the question. I wish they would add must eliminate if they are certain and correct about the ones they eliminate. What I mean by that is, let's say that I'm absolutely positive 0 is not right, because there seems to be some benefit in guessing. I'm going to eliminate the ones that I'm absolutely positive. So let's say that question A we know is wrong, maybe not in this question, but just in a hypothetical question. Now notice, by purely guessing, you have a 1 in 4 shot of getting the right answer, and notice that's a different probability. So here the probability of getting it right out of a guess is 1 in 5. Here the probability of getting it right from a guess is 1 in 4. Let's keep eliminating. Let's say we could definitely eliminate 2, and you're positive you could eliminate 2. That's kind of key to this problem. Then you'd have a 1 in 3 shot of getting the question right by purely guessing, and that's the probability of 0.3 repeating. Now let's go ahead and do our expected count. So this is an expected count question. What could you expect to get? And you just want to add up xi, pi. Okay, so if you ended up, what would be your expected points? Okay, so you could expect to get 7 points, correct, but you only have a 1 in 5 chance of that happening. Okay, plus you could get no points, right? And that would be a 1 in 8 chance, or 4 out of 5, right? 4 of them are wrong, 1 of them is correct. There's only 1 correct answer here. So this is what I could expect to get. If I change this instead of to a fraction to 20%, it's the probability of getting it right if you're totally guessing, and 0 times any number is 0, I end up getting 1.4. So if it's a 5-question test and you totally guess, your expected point value per question is only going to be 1.4. All right? Now, let's do it if I totally know that one of them is wrong and eliminate it. Now I'm going to find what should I expect to get in points. So again, I get 7 for a correct answer, But now notice, remember, I have a higher chance of getting it right. I have a 1 in 4 chance of guessing and getting it right. And then once again, I get no points for wrong answers. So I have a 3 in 4 chance, which would be 75%. I have a 3 in 4 chance of getting it wrong because 1's right and 3 are wrong. Now when I do this math, I end up getting 1.75. So notice by eliminating 1, my expected count goes up. Let's keep going. Now, let's do 1 and 3. If I have 1 and 3, but notice it's still not more than just purely leaving it blank. So I got to keep eliminating choices until I see that there is no benefit in eliminating, and I'm going to go ahead and guess. So let's take a look. That would be 1 in 3, or 0.3 repeating. You have a 1 in 3 chance of getting it right if you've eliminated 2 incorrects. And you have, just by guessing, a 2 out of 3 chance, and that'd be 0.6 repeating. Now when I multiply these for an expected count, I get, looky there. So if you can eliminate 2 choices in this example, you actually stand to get more points on average per question than by leaving it totally blank. So this would be a good idea to go ahead and keep eliminating until you've narrowed it down to 3 and then guess. So the question asks, how many should you eliminate? And my answer here would be 2. It's advantageous for me to go ahead and eliminate 2. So that therefore I get more points on average than just totally leaving it blank. Thanks for joining us.